Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the lesson on resolving forces, and in this video I'm going to be going through a specific example. So here we go, we have a trolley of mass 4 kilograms accelerates along a rough horizontal plank pulled by a light inextensible string, making an angle of 35 degrees to the horizontal. If the tension in the string is 24 newtons and the box experiences total resistive forces of magnitude 8 newtons, by modelling the box as a particle, find the acceleration of the trolley and the magnitude of the normal reaction between the trolley and the plank. Right, so I'm just going to label this diagram here with all the information that I have. So I know that the mass of the trolley is 4 kilograms, so I'm going to write that on the box there. Now, a rough horizontal plank implies that there's going to be some friction, and that is the result of these total resistive forces of magnitude 8 newtons. So the resistive forces are being caused by the fact that it's rough. So I'm going to draw a force arrow on here, resisting the motion, and label that with 8 newtons. Now the fact that I'm putting the resistance in that direction means that I've assumed that the particle is accelerating in this direction, positive direction to the right for this one. What we also have is a light inextensible string making an angle of 35 degrees to the horizontal. So I'm just going to move that arrow over there so that I can do a force there which is 24 newtons. And that's making an angle of 35 degrees to the horizontal. So let's draw that in there. That angle there is 35 degrees. Now, other forces that I'm going to be looking at acting on this system, one is the weight of the particle, and the other is a normal reaction force. Now, the weight is going to be mass times gravity, which is 4g, and then we have a normal reaction force R. So I've labelled all the forces acting on the system now. What I'm now going to do is resolve this force, which is at an angle, into its 2 component parts. So I'm just going to add in the vertical component of that going up in that direction, like so. And I'm going to label this one that's adjacent to the angle, I'm going to label as 24 cos 35. This one that's acting vertically opposite to the angle, I'm going to label as 24 sine 35. And what I now have is my forces and components all acting either horizontally or vertically, and I can look to resolve that now. So, the acceleration of the trolley along the plank, I need to be looking horizontally here. So I'm going to resolve in the direction of motion, taking this direction to be positive, and I'm going to use the equation that resultant force is equal to mass times by acceleration. Now the resultant force horizontally, we've got the force that's pulling the box, which is this 24 cos 35, minus the resistive forces, which is this 8 newtons, which is acting in the opposite direction. And that's going to be equal to the mass, which is 4, multiplied by the acceleration. So I'm just going to get a numerical value for the left-hand side of my equation, 24 cos 35 minus 8, which is 11.659, is equal to 4a. And then dividing by 4 and rounding to 3 significant figures, I get that the acceleration is 2.91 meters per second, and that's to negative 2. So that's part A, that's the acceleration. Part B was asking us to find the magnitude of the normal reaction force. Now that's this force R, and to do that I'm going to need to resolve vertically. So I'm going to need to consider all the forces acting either straight up or straight down. So looking now at resolving vertically. storm units, if you're wondering. Vertically, what we have going on here is because the particle is only moving horizontally, it's in equilibrium vertically. So I'm just going to say that up equals down. So the total force is up, which is going to be R, my normal reaction force, plus 24 sine 35, is equal to the force is acting down, which is just the weight, 4g. Now, remember that in maths we take g to be 9.8. So what I'm going to do now is I'm going to do 4 multiplied by 9.8 and subtract 24 sine 35 to get my normal reaction force to 3 significant figures to be 25.4 newtons. So there we go. Resolve horizontally to find the acceleration, resolve vertically to find the normal reaction. I'll see you in the next video.